So we want to know about internal conversion, external conversion and inter-system conversion from this particular energy level diagram. So first of all, interconversion means the form of radiation less relaxation in which the analyte moves from a higher energy level to lower energy level. Then in case of external conversion, from a radiation less relaxation in which energy is transferred to a solvent or to the sample matrix. So the intersystem crossing becomes a form of radiation less relaxation in which analyte move from a higher energy electronic energy level to the lower electronic energy level with a different spine. So in this, common thing is a radiation less relaxation, but in case of internal conversion, when analyte moves from higher energy level to the lower energy level, and in case of external conversion, there is an energy transfer to the solvent system, and in case of the intersystem crossing, there is the analyte moves from higher energy level to the lower energy level with a different spine. So we'll come to know what is this by this diagram. So this is the internal conversion, then external conversion and particular intersystem crossing. So these are the relaxation of particular radiation. So it becomes the radiation less relaxation in a particular internal, external and intersystem crossing. Only difference is the external is for transfer energy to the sample and sample matrix. Then example of the molecular excitation and emission spectra. So the excitation spectra, it is indicated by the x and y axis, that is respectively wavelength and emission spectra. Where is the excitation emission intensity? So emission spectra of fluorescence or phosphorescence spectrum in which emission intensity is fixed wavelength. So these are the function of the wavelength for the excitation. In this case, S0 to S2, S0 to S1 is excitation spectrum, and for particularly for this is the emission spectrum for the fluorescent and it is for phosphorescence. It is denoted by the fixed wavelengths. Then factor, important thing is factor affecting on fluorescence. So there are lots particular factor is the nature of molecule, nature of substituent, effect of concentration, then absorption, light, oxygen, pH, then photo decomposition, then temperature and viscosity, quantum yield, intensity of the incident light and path length. So these are n number of the factors that are affect the fluorescence intensity. So first is nature of molecules. So all the molecule cannot show the phenomena of fluorescence. Only the molecule absorb the ultraviolet and visible radiation can show the phenomena. So great, the absorbance or absorptivity of the molecule is the more intensity of the absorbance. So absorbency is depending upon the particular intensity of the fluorescence. Then, because it is directly proportional. The next is nature of the substituent. Electron donating group enhance the fluorescence. For example, NO2 OH group, amino group and a particular alcoholic OH group. Then electron withdrawing group decreases or destroy the fluorescence. That is acidic group COH, NO2 group, nitro group and double bond N containing compounds. So donating group, withdrawing group. Donating group enhance the intensity and withdrawing group decrease or destroy the intensity. Then high atomic number. Number that is introducing into the electron system decrease the fluorescence. So high atomic number decrease the fluorescence. Then many atomic and heterocyclic compound, aromatic and heterocyclic compound, fluorose the particularly if they contain certain substituent group in it. So substituent group, it is increase the fluorescence intensity. Then multiple conjugated double bond favors the fluorescence. So multiple conjugated double bond also favors the fluorescence. So these are the chemical nature of the substituent that affect the intensity of the fluorescence. Then nature of molecules. All the molecule cannot show the already we know. Already we discussed about this. The next is the effect of the concentration. Fluorescence is directly proportional to the concentration. Already we know about phenomena that is fluorescence is directly proportional to higher concentration. That will give higher fluorescence. Then particular absorption. So extreme sensitiveness of the method is required very dilute solution. So to know the concentration, so we use the dilute substance for first of all, and then we get idea about this. Then absorption of the fluorescent substance on the container will create a serious problem in this case. So hence the strong solution must be diluted. So because this is very highly sensitive method, so we use the dilute solution to get proper absorption and of the light and use the intensity of the radiation in this case. Then light. So monochromatic light is essential for the excitation of the fluorescent substance. In the intensity will vary with wavelength. So whatever the light source we use for this analysis of this fluorescence phenomena, we want a monochromatic light because that will give or affect the intensity of fluorescence. Then oxygen. So in the presence of oxygen, many interfere in two ways in this intensity of the fluorescence: by direct oxidation of the fluorescent substance to the non-fluorescence, and by quenching of the fluorescence. So what sometimes it is directly oxidation takes place in fluorescent substance, and that vary the intensity of the fluorescent substance in this case. So it may be affected. This is the first way. The second way is this quenching of the fluorescence. Quenching means we stop or decrease the fluorescence property of some substances if it is interact with oxygen. Then next is a pH. The fluorescence of many molecule is generally pH dependent because the ionized or non-ionized form may be fluorescence. So pH is very important, play a role for this fluorescence property or intensity also depend on pH. So an alternation of the pH of the solution will have significant effect on fluorescence ultimately in this case. Then temperature and viscosity. Increasing the temperature and decreasing viscosity will decrease in the fluorescence. It is the ratio of this or it is the way of particular temperature on viscosity and ultimately on a fluorescence. So increasing in temperature decrease the viscosity and decreases the fluorescence. Then intensity of incident light. This is factor that is increase the intensity of the light incident on sample decreases fluorescence intensity. So intensity of the light is also important, that will affect on fluorescence intensity. If it increases the intensity of light, in sample increases fluorescence intensity. The intensity of light depending upon light emitted from the lamp, excitation monochromator and excitation slits width. So these are the some important point including in the intensity of the incident light. Then path length. The effective path length depend on the both of excitation and emission slits width. So excitation and limited slits particular length is very important to get a proper intensity of the fluorescence. So use of microcuvette does not reduce the fluorescence, but use of microcell may reduce the interference with the increase in the measured fluorescence. So path length is also affect on the intensity of the particular fluorescence. Then remaining point that is quantum yield. So it is a quantitative expression of the efficiency of the fluorescence is a fluorescent quantum yield. It is psi f, so indicated by this. So which is a fraction of the excited molecule returning to the ground state by the fluorescence. So quantum yield range from 1 when every molecule in an excited state under the fluorescence to the 0 when fluorescence does not occur. So quantum yield is very important in this case, that affect the intensity of the fluorescence. Then important thing is what is quenching then, and fluorescence quenching means what? So it is nothing but the vanishing or decreasing and stop the fluorescence. Quenching means, so this is the substance in effect compete for the electronic excitation energy and decrease the quantum yield, or sometimes it vanish the quantum yield or vanish the fluorescence. So the iodine and the bromine substance decrease the quantum yield in case of this. So these are the quenching substances or vanishing the fluorescence. So decrease in the fluorescence intensity is due to the specific effect of the constituent of the solution, or due to the concentration of pH, pressure of the chemical substance, temperature, viscosity, etc. So that may produce the quenching. So type of quenching: cell quenching, chemical quenching, static quenching, and collision quenching. So these are decreasing parameter of the fluorescence: cell quenching, chemical quenching, static quenching, and collision quenching. So here decrease in fluorescence intensity due to the factor like the pH, presence of oxygen, halides and heavy metals. Then pH aniline at 5 to 13 gives fluorescence, but at a pH lower than 5 and lower than 13 it does not exist in a fluorescence, or greater than 13 does not exhibit the fluorescence. Then halide like chloride, bromide, iodide, and electron withdrawing group like NO2, COH leads to the quenching. Then heavy metal leads to the quenching, becomes a collision of triplet ground state also. Then fluorescence instrumentation, next point. So this for the instrumentation of this, so particular fluorescence. For the fluorescence measurement, it is necessary to separate emitted radiation from the incident radiation, and this is most easy done by the measuring the fluorescence at a right angle to the incident radiation. The fluorescence radiation is emitted in all direction, but incident radiation passes straight through the solution. So this is the block diagram for the molecular fluorescence spectrum meter. That is the first is the source, then chopper to adjust the particular monochromatic light, and excitation wavelength selector is there, and incident on the sample, then emission wavelength is selector is there. After detector is there, we detect the wavelength and intensity, and it gives the signal to for the processor, and we'll get the result. So instrumentation include the source of light, filters, monochromator, particular sample cell, and detector. So simple fluorometer design. In this case, UV source is used, filter, particular one filter is used, then sample holder, second filter, and detector. So filter first remove the wavelength shorter than those would pass through the filter 2 and appears as a fluorescence, and second filter removes the scattered excitation wavelength and passes to the emitted fluorescence. The first is sources of light, that is mercury arc lamp, xenon arc lamp, tungsten lamp, and Tyndall dye laser.